Hello everyone, welcome to the Electron Flow Academy. So today we are going to discuss about the numerical problem number 3 based on the transformer's EMF equation. Okay, so question is as follows. A 20 kVA single phase transformer has 300 turns on primary side and 15 turns at secondary side. Okay, next is that the primary is connected to a 1000 volts 50 hertz supply. So there are some following parameters which we need to determine. First one is the secondary voltage on the open circuit. Okay. Second is the maximum value of the flux. And last one is the value of current in both winding at full load condition. Okay. So there are some parameters given to us here. So let's start the solution. So here given firstly the question is given us that 20 kVA, that means secondary side power, that means E2 into I2. 2 stands here meaning that secondary side. Okay, so this is equal to 20 into 10 to power 3 kilo VA. Okay, 10 to power 3 is kilo. So this is given to us. Next thing is that N2 is equal to 15, N1 is equal to 300, E1 is 1000 volts. Okay, and frequency is equal to 50 hertz. Okay, so those parameters are given to us in the question. So let's start the solution. We know that E2 divided by E1 is equal to N2 divided by N1. Okay, we know this ratio. So from this formula, we can calculate the value of E2. Okay, so basically E2 is equal to N2, that means 15 divided by 300 into E1. The value of the E1 is here 1000. So this is how I can calculate the value of the secondary induced voltage. So secondary voltage is equal to here 50 volts. Okay. So basically this 50 volt is the secondary voltage on open circuit. Okay, open circuit. So basically this is the secondary voltage on open circuit. Okay, when the secondary is not connected to any load. So there is another condition is given us that secondary current at full load. Okay, next thing is that secondary current at full load. That means here I2 is equal to, from this expression I can calculate the value of I2. Okay, so I2 is equal to 20 kilo, that means 20 into 10 to the power 3 divided by E2. Okay, so value of the E2 I just calculated here. So 20 into 10 to the power 3 divided by 50. So this is how I can calculate the value of I2, which is equal to 400 ampere. Okay, so this is secondary current at the full load condition. Okay, so next thing is that if I assume that assuming ideal transformer That means there is no losses in the transformer. So that means the expression which is I1 into E1 is equal to I2 into E2. Okay. So we know the value of the I2 into E2. I2 into E2 or E2 into I2 is equal to 20 kVA. This is given to us. So this is equal to, basically when we discuss your, when we said that the transformer is lossless or ideal, that means the primary power is equal to the secondary power. Okay. So that means this expression is equal to 20 into 10 to the power 3. Okay. So here primary current at full load, meaning I1 is equal to nothing but the 20 into 10 to the power 3 divided by E1. So the value of the E1 is given to us, which is equal to, this is 1000 volts divided by 1000. So the value of the I1 here, I get 20 ampere. Okay. So what we have calculated till now, we have calculated the secondary voltage on open circuit. We have calculated the value of the currents in the both windings. Okay. Next is that maximum flux or maximum value of the flux. So let's see. Next thing is that maximum value of flux in the core can be found as, we know that formula, or we can say that the EMF equation of the transformer is that phi m is equal to E1 divided by 4.44 F into N1. If I talk about the primary side, then the value of the maximum flux is equal to, the value of the E1 is 1000 divided by constant 4.44 into 50 hertz. Frequency is given to us in the question, frequency, and multiplied by number of primary turns, which is equal to 300. Okay, this is given to us in the question. So from this expression, I get the value of the maximum flux is equal to 0.0150 Weber. Okay, so this is my second parameter, which is asked in the question. Okay, so this is how we have calculated the, or we have determined the asked parameters. Okay, so thank you very much. Please like and subscribe our channel.